Hi friends, I am Himabindu from Women Who Code Delhi and welcome to another video of Tech Bytes. In the last video, we looked into the difference between machine learning and deep learning. In this video, let us look into what's the intuition behind deep learning. Coming over to what's the main idea behind artificial intelligence. It is to make the machines think and learn like we do. Deep learning, being a subset of AI, also has the same goal, that is, to make the machines learn. This is done by using a set of algorithms which are inspired by the working of human brain. Now arises the question, how do humans learn? With the help of the brain, pretty obvious. So, if we want that our machines should learn, then we have to incorporate something which is similar to our brain. That is, we have to make a formula or some mathematical model and fit it into our algorithms. But brain is a very complex organ and it is difficult to make a formula or some mathematical model out of it. Although it's a complex organ, but its building block neuron is quite simple to understand. Now let us move on to neuron. So what is a neuron? Neuron or nerve cell is the building block of brain. And in this we are interested in basically three parts of it. One is the dendrites, other is axon, and the third one is the synaptic terminals. The dendrites collect the information from outside environment and then based on some conditions it passes on the information received by the dendrites to the axon and then it is transferred to other neuron or nerve cell via the synaptic terminals. This is the basic structure of the neuron, and now let us look into how does neuron help in learning. Before we get into that, first let us look into some important terms. One is threshold potential, the other is resting potential, followed by synaptic connections. Neuron transmits information via electric signals, and when the neuron is at rest, the potential is called resting potential, and when an input signal arrives, it causes some changes in the potential of the cell membrane, and then this potential, if reaches the threshold potential, then the signal is transmitted, otherwise it is not transmitted. The membrane potential which I was talking about develops in this path. Let us see a detailed diagram of this path. So this is the axon and this is the myelin sheath, and the potential is formed around this axon. So when a signal is passed by the neuron, it is said that the neuron has fired. That is, if the potential developed is greater than the threshold potential, then the neuron fires. Otherwise, it doesn't fire. This is a plot between membrane potential and the time. Here, as you can see, initially the neuron was at rest and then there was a stimulus applied. That is, some input signals were sensed by the dendrites. And when the input signals came, it affected the potential, the membrane potential of the neuron. After some time, it reaches the threshold potential, and as soon as it rises above the threshold, the signal is passed via the axon to the other neuron, and after passing the signal, it again comes to its resting potential. So till now we covered what is resting potential and threshold potential. Now let us look into what is a synapse. Synapse is a junction between two nerve cells or neurons, and the transfer of signals between two neurons is called synaptic connection. Till now we saw a brief of how neuron works. Now let us look into how does it help in the process of learning. Whenever we learn something new, a new synaptic connection is formed. These connections become stronger as we recall and revise that thing more often. It's a common experience that sometimes we are not able to recall things during our exams as we read that topic long back, right? Due to the lack of revision, the synaptic connections were not activated frequently and hence the strength of the connections decreased with time. By now we can see that there is a relation between the strength of the synaptic connections and learning. Now let's move on to Hebb's rule. It states that changes in the strength of synaptic connections is proportional to correlation in the firing of the neurons. That is, if the neurons fire together more often, then the strength of the synaptic connections is more as compared to when they are not activated together. Before moving further, let us quickly look into what is correlation. It is a measure of the strength of a linear relationship between two quantitative variables, for example height, weight, etc. Quantitative refers to those things which can be measured. Here are a few plots for correlations. The first one is positive correlation, the second one is negative correlation, and the third one is no correlation. In the positive correlation, you can see that as the variable on the x-axis increases, y also increases. While in the negative correlation, as x increases, the y decreases. That is, it has a negative gradient. This refers to negative correlation. And no correlation means there is no connection between the two variables. So this was all about the Hebb's rule. Although the formula could relate the learning to some statistical variable, we still need a mathematical model for implementing the neuron. And here comes MP neuron model. McClock and Pitts gave a mathematical model of neuron and hence it was named MP neuron. The MP neuron model has four basic components. The first one is inputs, second one is adder, weights, and then activation function. These are the inputs x1, x2, x3 up to xm. So there are m inputs here and corresponding to each input is weight, w1, w2 and so on up to wm. The adder takes in the inputs and weights. It multiplies the input with the corresponding weight and then adds up all such products and passes that value to the activation function. This activation function decides the output. Now let us take an example. Suppose that there are four inputs x1, x2, x3 and x4 and the corresponding weights are w1, w2, w3 and w4. Let us assume the inputs to be 1, 0, 0 and 1 and the corresponding weights to be 0, 0.5, 0.25 and 1. We can assume any values. For example purpose, I took these values. Now let us add up these values according to this function. So h is equal to w1 into x1, that is 1 into 0 which gives us 0, plus w2 into x2, that is 0.5 into 0, then 1 into 0 also gives us 0, plus 1 into 1 gives us 1. So the final answer given by the adder function is 1. So till now what we did is we took some inputs and weights, added them up using adder function, and then now we are going to pass this value to the activation function. Let us see what activation function looks like. Y is our output which is equal to the activation function g of h. The activation function takes the value given by the adder function and it is 0 when h is less than equal to theta. Theta is our threshold here and it gives us 1 when h is greater than theta. Now let us assume the theta to be 1. So if theta is equal to 1, then since the h we got here is also equal to 1, the activation function would result in 0. So our output will be 0 for this set of inputs. In this video, we looked into neuron, Hebb's rule, and a small introduction to MP neuron model was given. In the next video, we will see how MP neuron model could mimic the biological neuron. Thanks for watching.